This is our video on Riemann sums.
Okay, so we are doing number 16 Riemann sums for the video. So we're going to start with the definitions. A Riemann sum signifies that there are rectangles involved, and we're going to be taking the definite integrals. And so remember that a Riemann sum is an approximation of the definite integral of f of x with respect to x on the interval a, b, that's a closed interval, using rectangles to estimate area. So then if we look down a little bit, we're going to get our equation for a Riemann sum, which is r sub n equals, and then we have our summation with the n on top, which is going to be some sort of integer that's going to tell us how many rectangles, and over k equals 1, and f of c of x times delta x sub k. So, now that we know this, each subinterval of our Riemann sum is of width b minus a over n, which we will symbolize as delta x. So those are just the definitions. And now we're going to go into some summation definitions over here. We have, right here we have a is equal to the left endpoint, b equals the right endpoint, and n equals the number of triangles. Those are number of rectangles, that's my bad. We're going to plug that into our equations, especially for the subinterval amount, b being the right endpoint, a being the left endpoint, and n being the number. Then the endpoints of the intervals for which we're going to use our calculations they differ for each one, but generally we're going to have for c naught, a plus 0 times delta x is less than a plus 1, wait, is that less than, or that, no, that's just the next one. That's my bad. So the next one would be a plus 1 times delta x, which is c1, which in the next one is a plus 2 delta x, which is c2. And so then now we're going to look at, when we're taking a left Riemann sum, a right Riemann sum, or a midpoint Riemann sum. Pardon the Texas accent, I don't know how to say Riemann. But either way, for a left one, we're going to start off by using a, which is our left endpoint. And we're going to use the function value at a, and we're going to end up adding all these up. These are which part of the c sub x. But anyway, you use for left the a, and then the a plus delta x, a plus 2 delta x, and so on until you get to a plus n minus 1 delta x, depending on how many subintervals you have. For right, you have a plus delta x, a plus 2 delta x, a plus 3 delta x, and so on until you get to b. You're going to be using the right endpoint instead of the left endpoint for the right Riemann sum. Do it. For a midpoint Riemann sum, you have a plus 1/2 delta x, a plus 3/2 delta x, and a plus n minus 1/2 delta x. And that's going to go on until we get to that. And so then our final little bit of, not vocabulary, but equations we're going to look at are the summation equations and identities that help us with the i's. And so then a summation of a constant is equal to the constant
Times the number of rectangles.
Yep, and this is my partner. He has a cold, so we're trying to save his voice. The second one, we have a summation of I is going to be equal to n times n plus 1 over 2, n being the number of rectangles again. Then a summation of I squared is equal to n times n plus 1 times 2n plus 1, all divided by 6. And then I cubed is equal to n squared times n plus 1 squared over 4. Alright, so now we're going to put this into practice. What we have is an equation, y equals x squared plus 4 on the closed interval 0, 8. And so first we're going to be looking at a left Riemann sum. And so initially looking at the graph, we see that it's rising exponentially. And we can tell that it's going to be an underestimation just based on it having to touch the left endpoint. And so we start and we write our Riemann sum using r sub 4 because we're going to be wanting to use 4 subintervals, which is given. And so we have a summation with 4 on top, that's how many, n, over k equals 1, and then f of c sub x times delta x. So first we're going to solve for the delta x in this equation. And delta x, as we know from earlier, is equal to b minus a over n, the number of rectangles. And so b, the right endpoint here, is 8. 0 is the left endpoint, and that's a. And then n is going to equal 4 because we're trying to use 4 subintervals. So we have 8 minus 0 over 4 is equal to 2. So delta x equals 2. Now looking at the equation, we're going to want to find c sub x so that we can later plug that in to the f of for the graph. So c sub x, as we earlier learned for a left Riemann sum is equal to a plus delta x plus a plus 2 delta x plus a plus n minus 1 delta x. All right, so the first one is a, and the left endpoint here is 0. So our first one is 0, our first subinterval. And then the next one is going to be a plus delta x. Delta x is 2. So 0 plus 2 is going to be 2. 0 plus 4, 2 delta x. 0 plus 3 delta x is 6. So our 4 points are going to be 0, 2, 4, and 6. So there's our 4 subintervals. And so now we're going to plug these into the function and see what values we get. At 0, the function is equal to 4. At 2, it's equal to 8. At 4, it's equal to 20. And at 6, it's equal to 40. So now we're going to add all these up to get a f of c of x, and that is equal to 72. So then to get the Riemann sum, as we see earlier, you have to do the f of c of x, which we have is 72, and delta x is 2. So you multiply the two together, and the area under the curve and the definite integral for this is going to be 144 units squared. So now a right Riemann sum. Whew, okay, so we're going to do the exact same thing. We're going to look at it, and initially we can tell, hey, it's going to be an overestimation because it uses the right endpoints, and specifically this rectangle right here, that one is going to give us a very large overestimation. So we look at it, and the first thing we're going to do is find delta x. We're using 4 subintervals again. So you use b minus a, b is 8, a is 0, n is 4, which gives you 2. C sub x, we're going to do a little bit differently than the earlier one because now we're using a plus delta x, a plus 2 delta x, a plus 3 delta x, all the way to b. So we do this, and a plus delta x is 2, a plus 2 delta x is 4, so on. So we get 2, 4, 6, and our b value is 8. So now we're going to plug this into the function, and at 2, 4, 6, and 8, we get 8, 20, 40, and 68 respectively. So we add all these up, and we get 136 times the delta x, which we know is 2, and so we get 272 units squared. So we can tell that one is an underestimation, one is an over. The midpoint Riemann sum is probably going to give us something a little bit in between. So you look at it, and the graph fits it more, the function more. So we're going to start by doing the same thing, just with a little twist on the c sub x. So delta x, you look at it, and you say, hey, b is 8, a is 0, n is 4. So we get 8 minus 0 over 4 is equal to 2. Delta x equals 2. C sub x, we have 0 plus 1. We got to go back. A plus 1 half delta x, a plus 3 half delta x, a plus n minus 1 half delta x. So the first one is 1 half delta x. Delta x is 2. 2 times 1 half is equal to 1. So we have c of x at 1, then 3 halves times delta x is 3, and so on, gives you 5 and 7. So when we plug these into the function, and we get 5 at 1, we have 13 at 3, 29 at 5, and 53 at 7. We add all these up to get 100 even, times delta x is equal to 2, and times delta x, which is 2, gives us 200 units squared. And so these are the Riemann sums. We got to get Jansen to the football banquet, so thank you, Miss Hill.